Hi everyone, I'm Palina from Runtime Verification, and today I'm going to present our comprehensive approach to security that we have at RV because I believe that it can significantly improve the security stance of projects and even make it more sustainable for them. I'd like to represent this project as a pyramid where lower layers enable or at least make it easier to get the higher layers right. And currently the standard is to implement the code and just hand it over to some external auditor or a contest for a one-off audit or code review. And while it is a pretty good baseline, it also doesn't do much in terms of continuous security assurance. And that is very important, especially for protocols under active development. If the team has resources or feels like it, some projects also have some documentation outlining what the code is actually supposed to do, or even use some tooling to do unit testing or fuzzing. And while the completeness of those is very much hindered by the constraints in the development process, having more complete documentation and some tests actually helps make sure that the audit is actually going to go well, because it adds an additional dimension to it, since the auditor can not only check for some common vulnerabilities, but also for the adherence of the code to the business logic that they're supposed to implement. And having tests obviously is good too. A more comprehensive approach, however, adds some more layers, and maybe counterintuitively, we actually think that it makes the security model more sustainable. And one of the steps that is often overlooked is the design review. That's where some person, an auditor, looks through the design, understands what the project is actually supposed to do, and how does the architecture looks like, and sees if it actually makes sense. Because if the design doesn't, then none of that matters, actually, because the protocol can still be compromised. And the good byproduct of that is that it also allows you to write better properties and specification, outlining what the code should or should not do. And once formalized in the forms of tests or proofs, that actually enables the application of more advanced tooling. We can have more complete fuzzing test suites, we can do formal verification for even better security guarantees, and the best part of that is that we can also run them on CI. And I genuinely believe that having automated security processes is good. Adding more automation is better because it makes it harder to just skip through certain steps. It ensures that the security protocol is actually followed consistently. And also CI, in that sense, works as sort of an automated audit that is going to be run on every PR or every commit. Well, that's less expensive than having a human look through it over and over again. So as an example of something as an example of how it is important to follow through this whole process, I have this example that may or may not be based on a recent hack, and that happened to the protocol that helped users convert their BTC into an equivalent amount of wrapped BTC that we'll call Devcon BTC. And it was running on BTC chains, so it was supposed to work with native tokens, but it was also running on other networks which had Ethereum as a native token. And there was a change that actually made it possible for users to mint an equivalent amount of Devcon BTC for Ether, and Ether is like 20 times cheaper. So the hacker actually just minted a lot of free money, basically. And the thing is, there was a property that just hasn't been enforced, or maybe hasn't been formulated, that the user should also not be able to convert non-BTC tokens into, the wrapped version of BTC. And this property could actually have been enforced with something as simple as a unit test or this fuzzing test that you can see on the slide that just checks that if the protocol is running on Ethereum mainnet, then whenever someone tries to mint tokens using Ether, this transaction fails. So that is a foundry test. Has it been running on CI? It maybe could have caught the issue as soon as this code was pushed, but before the deployment. So to summarize, the points I want to make here is that security is complicated. I think everyone knows it. There are a lot of steps in this process. It's very important to get all of them right. Automation is very useful because it helps ensure that the security process is followed consistently and is enforced. And in addition, CI also provides a very efficient and a very cost-effective way to ensure that new updates don't break anything. One last thing that has been missing so far is this base layer, which I haven't really touched in detail, that is OPSEC, because unfortunately there have been a lot of private key compromises in the past year, and if the private key is compromised, then unfortunately even a very secure smart contract code can also be exploited. And there are a lot of resources about how to get it right on the internet. So I encourage all of you to look through it. And yeah, thank you very much.
Thanks, Palina. Any questions for Palina?
I guess my one question would be around maybe fatigue in terms of continuing to be diligent about making sure that the basics are in place. And I'm curious for you what has helped to maintain those habits over time.
Thank you. Yeah, we try to follow these processes religiously at RV. Automation helps a lot because you don't have to, go over the same things over and over again. Instead, you write some properties you specify some properties, and then you formalize them in the forms of tests or proofs with a lot of formal verification. So that's what we try to set up. And then whenever code changes, that actually handles it for us to a large degree. I think it actually, having the process makes it easier.
Cool. Next
one. Yeah, question on blockchain security, where you have smart contracts, which is immutable, versus, let's say, on Web 2, where you can update your code if you discover a security problem after the fact. So how does that factor in?
Oh, you mean upgradability?
How would you, not necessarily, but let's say you don't have upgradability, then how would you modify your security practices such that that doesn't, so that you mitigate that, I guess?
Right, got it, thank you. Well, I guess that's why you try to get it right the first time before deployment. That's why we advocate for a very comprehensive security analysis that you perform before deployment to make sure that you go through all the stages, that the team writes proper documentation, helps us formulate the properties and invariants that should hold, that can later be monitored. We advocate for formal verification to ensure that there are the best security guarantees. I guess there are there is a field that deals with some post-hack things or recoveries, but I guess that's a different story. We just suggest that people should get it right, and I think we're getting better.
Cool.
Is there something like the OWASP Z-attack proxy equivalent in smart contracts or blockchain frameworks that you'd recommend?
Sorry, can you please repeat once again?
The Open Web Application Standards Project, the Z-attack proxy that they have. We used to use it in our CI tooling in Web 2 sort of development to test for the top 10 OWASP security vulnerabilities.
Right, yeah, I haven't been aware of that, but it sounds pretty useful. I'm all up for using any tooling that helps and having it on CI. I guess anything would help. Static analyzers are great. As the first step, especially. Having unit tests is also extremely helpful and very efficient. Fuzzing can uncover a lot of vulnerabilities. So yeah, thanks for letting me know about that.
Okay, one more question.
Thanks. You mentioned a design review as a precursor to the actual code review. Is your hope or expectation from an audit point of view that a team comes to you with the design before they even write the code, or were you just talking about that as a specific phase of the audit?
That is perfect, but that almost never happens. Okay. So the sooner we introduce security and some testing, any of that, into the process of development, the easier it becomes for everyone. That's something that we have found out ourselves, but it almost never happens. So we at least try to allocate some time for design review first before we dive into the code itself to make sure that we also understand what it's supposed to do. But I mean, having the team providing us the design first is ideal, and we can also help out with the stages, but it's pretty rare because of the resource constraints, I guess.
Great, thanks.
Okay, we can take one more question, if there is any. There's one there.
Thank you. I'd like to know if there are some security best practices for smart contract based on artificial intelligence. Thank you.
Based on artificial intelligence, right?
Yes.
Right. I am aware of a few tools that do it. I think you can also ask ChatGPT to generate you some security practices, and it will be pretty helpful when it comes to like common vulnerabilities. I guess the current common problem with all this AI-based tooling is that it is good at pattern matching, right? So it can definitely help you find some common issues that are known for a long time, but it probably has bigger issues with like business logic or design review parts. So I guess it's pretty helpful, at least when it comes to the first part.
Okay, that's everything. Thank you, Palina. Let's give it up to Palina.